Windows Azure Mobile Services deep dive. Thank you for joining Vinwire Technologies here. So I'll get started with the webinar. Okay. As Noor has introduced, my name is Amit Dubey. I'm the Director of Mobility and Cloud Business at Vinwire Technologies, and I'll be taking you through this session today. Okay. Before we begin, let me talk something about Vinwire Technologies. So we are an IT services company. We work on Microsoft platform and mobility. So as you can see from this slide, like we work on multiple platforms such as iOS, Android, Windows 8, and then we are partners with Accelerator and Xamarin, which are like cross-mean platforms to build mobile applications. We do a lot of work on Microsoft, namely Windows Azure, custom app development using .NET, SharePoint, SQL, BI, and stuff like that. So that was a short introduction about Vinwire. Moving on, the agenda for today's webinar is like, firstly I'll be talking about Windows Azure Mobile Services. I'll give you a brief overview about what it is and what it provides, and how you can use it to build a cloud backend for your mobile applications. And then we are going to talk about how to store the data in cloud using Windows Azure Mobile Services and the different options that Windows Azure provides for storing the data in the cloud. We also want to talk about push notifications that you can send using Windows Azure Mobile Services and the notification hub provided by Windows Azure. And then we are going to talk about the authentication modes that are available for Windows Azure Mobile Services. Lastly, we're going to see how to monitor, alert, and scale up and down your mobile services. And then I'm going to quickly show you how to create a mobile services using the Windows Azure portal, and then how to create the sample app and then update that using Visual Studio. So let's get started. So Windows Azure Mobile Services is a Windows Azure service offering designed to make it easy to create highly functional apps using Windows Azure. So the goal of Windows Azure Mobile Services is to make it incredibly easy for developers to add a cloud backend to their client apps. Now, be it Windows 8, Windows Phone, iOS, or Android, you can use mobile services for any platform. And it allows you to easily store structured data in the cloud that can span both devices and users. So it gives you multiple options to store the data as well. We're going to see that as we move forward. And then it gives you user authentication and then push notifications. So these are the three major segments in Windows Azure Mobile Services that you get when you sign up for that. And we're going to talk about in more detail about all these features as we move forward. So let's start with the key scenarios when you can use Azure Mobile Services. First thing is multi-platform support. Now, as you see, like you have support for Windows Store apps, which are basically Windows 8 apps, and then you have support for iOS as well as Android. So you have SDKs available that you can download and then use it in your native apps for iOS, Android, or Windows 8. And then you can connect to the backend that is created by Windows Azure Mobile Services using the REST API. So one key thing is that you can have the same database or same services layer that is used across multiple platforms. So if you're building an app for different platforms, then Windows Azure Mobile Services can help you build the backend for that. And then it uses common scenarios like user authentication, push notifications and structured storage. So you get a number of options on user authentication. We're going to talk about more as we move forward. You can use Facebook, Twitter, or Google or Active Directory authentication for your mobile apps. And then push notifications are also available for multiple platforms, either using Windows Azure mobile services or using the notification hubs. And there is structured storage, for which you can use the SQL database on Azure to store your data in a relational database format. And then rapid development, like you can build a backend for your mobile app like within 5 minutes. You just have to go on the portal and then create a mobile service. It takes the database as SQL Azure database as the default backend, and then it creates all the required services for you within minutes. So you can just create that and use it in your app right away. So these are the key scenarios when you would actually want to use Windows Azure mobile services. Okay, so let's talk about the storage options that are provided by Windows Azure mobile services. So it is backed up by Windows Azure SQL database. So when you create a mobile service in Windows Azure portal, what it does is it creates a database for you. If you do not have an existing database, then you can create a new one or use the existing database that you have on Azure. And then it links the mobile service with that database that is going to store all that information for you. So it makes it incredibly easy for you to build the backend. And then you can create multiple tables depending on the needs for your app in the database. And then you can access that using the SDKs or the REST API that is provided by Windows Azure mobile services. So it is the SQL database is available by default for storage. And then there is multi-tenant database partition schema. Which means that if you want to use the same database for multiple applications, you can do that. You can partition the table by application name. So say for example, if I have two apps, app X and app Y, then I can partition the to-do item table by using appx.todo item and appy.todo item. So when you are getting data from app X, you get only data that is relevant to that particular application. And then similarly for application Y. So apart from that, another advantage is like you have multiple ways of accessing data. As I was telling you, like you can go to the portal, Windows Azure portal, and see the data that has been captured through your app, or you can use the SQL portal with which you can connect to the database and see the data or manage the data. And then you can use the SQL Management Studio that is installed on your local desktop or laptop, and then connect to the Windows Azure database and then manage the data from there. Apart from these three, there is REST API also available that you can use, and it has a rich querying capability and everything that is provided by OData for you. Moving on, let's see the key features that are available with SQL database on Azure. So as I was talking, there is an automatic service REST API generated for storage. So once you create a Azure mobile service, what happens is it automatically creates web services for you that work on the REST protocol, and the data exchange is in JSON that you can use for accessing the data from your backend. The second thing is the dynamic schema. Basically, this is a very interesting feature actually. What happens is like when you're creating a table, you can create it with specific columns. But then in the future, say for example, if you are wanting to have another column, and if you do not change the database, what happens is if you keep the dynamic schema on, and then if your data sends an additional column to the service, what it does is it creates a column on the fly. So that is a dynamic schema. You can add columns as you go without even going into the database and changing it. So it takes the schema from the data that you are inserting into the database. Next is like ability to author server logic that intercepts your CRUD operations. Basically, like you have functionality where you can write custom scripts actually that will execute whenever you actually do an operation like an insert, update, select, or a delete. So you can write custom scripts on Windows Azure portal that will be executed when a certain operation is going to happen on a particular table. And then you have rich querying capability. So this is like you can use the web services to query the data and specify your where clause, specify order by, move by, and then paging as well. So all these are available as part of your web services that are exposed by Windows Azure mobile services. So those are the features of structured storage, which is provided by the SQL database on Azure. The other options that you can use to store data is the Windows Azure Blob and Windows Azure Table. Now, anybody who is familiar with Windows Azure will know that these are the storage options that Windows Azure provides apart from SQL database. So Windows Azure Table is basically a flat set of records that you can store. They do not have RDBMS structure, they do not have relations as such, but you can create multiple tables and then store dynamic schema in that. And compared to SQL Azure, it is much cheaper storage option that is provided by Azure. And then secondly, you have Windows Azure Blobs. Now, if your app is going to say upload some documents or images or any kind of files, then you may not want to go for SQL Azure and then you want to store them as blobs. Then you can use the Windows Azure blob storage to store those files on Windows Azure blobs. And accessing these objects is basically very simple. Like as you see, there is just 2 lines of code to create a service for these objects and then use it within your app. So I say just where Azure is going to require Azure, and then I create a blob service using that Azure object, and then I have to provide the account name for your Azure account, and then the account key that is for every storage account that is created. So basically, Windows Azure provides you an account key for the storage account that you create. So once you pass those 2 parameters, you can create the service, and this service will allow you to query the blobs or query the tables, and then add, insert, update, delete the data in these. So I've given an example for create blob service. Similarly, you can create a service for the Windows Azure tables as well. All right. So those were the storage options that we saw, the structured storage and the Windows Azure table and the blob storage. The next feature that Windows Azure mobile services provides is the push notifications. Now, before we talk about notification hubs, I'd like to introduce you to what push notifications is. So as you know, smartphones and tablets are able to notify the users when an event has occurred. On Windows Store and Windows Phone applications, these notifications result in a post, which is a modeless window appearing at the top of the screen, or with a tile update on the start screen itself. Similarly, on Apple and Android devices, they are grouped in a notification window that can be accessed from the top of the screen. So if you pull it down, then you can see those notifications. So push notifications actually help the backends display fresh information on the mobile devices, even when the app is not active. So even if it is in the background, so the backend can send push notifications about the latest updates regarding the app to the user. And these push notifications are actually delivered through a platform-specific infrastructure called a PNS system. So a PNS offers barebone functions, and platform-specific PNSs have no common interface. So for example, in order to send notifications to a Windows Store app, a developer must connect to a WNS service. And to send a notification to iOS device, the same developer contacts APNS and sends the message. And similarly, you have GCM for Android notifications. So to overcome these problems, what Windows Azure Mobile Services provides is, like, it gives you something called as notification hubs that you can use. It's basically an infrastructure that makes it very easy to send push notification across different platforms. Now, say for example, if you're targeting multiple platforms, then you do not have to like send messages across from APNS, WNS, GCM. What you can do is you can create an account on Notification Hub, provide the keys and certificates that you get once you register your app with APNS, GCM or WNS, and then use this notification hub to target all the platforms at once. So let's see at a high level how PNS systems work. So basically it's the same pattern for all of them. The first step here is like the client application contacts the PNS to retrieve its handle. So the handle type depends on the system. For WNS, like Windows notifications, it's a URI or a notification channel as you call it. And for Apple notifications, it's a token that you get. The second step is like the client application stores this handle in the app backend for later usage. And for WNS, the backend is typically a cloud service. So for Apple, the system is called a provider. Third thing is to send a push notification, the app backend contacts the PNS using the handle to target an instance of a specific client application. And then finally, the PNS forwards the notification to the device specified by the handle. So these are the basic steps that are involved in sending a push notification. Moving on, let's talk about some of the features that are provided by notification hubs. First thing is the device registration, which is the registration management. So a registration is a sub-entity of a notification hub and associates a device PNS handle. Say for example, a channel URI device token, which is on a GCM registration or an Apple registration, with tags and possibly a template. So we will discuss about tags and templates as we move forward. So it is important to note that the registrations are transient. Similar to the PNS handles, they contain registrations expiration time. So you can set the time how long these registrations are going to stay on the notification hub. The maximum that you can specify is 90 days. This limit means that they must be periodically refreshed. So once it gets expired, so you have to refresh the registration. So another thing is like the automatic expiration here is important because let's say for example if somebody has uninstalled your app, that means that you do not have to store that registration all the time because the notification is not going to go to that device. So that's the reason there is a expiration limit on the registration that are stored on notification hubs. And the registrations must contain the most recent PNS handle for each device channel. So whenever you refresh, you have to update that with the latest handle that you have. Let's talk about routing and tag expressions. So tag expressions enable you to target a specific set of devices or specifically registrations when sending a push notifications to notification hubs. So the only way to target specific registrations is to associate them with a tag and then target that tag. So by default, like if you do not have any tags or tag expressions, what happens is like when you send a notification, it goes to all the devices. So if you want to filter it and then send it to a particular set of devices, then you're going to use those tags. So in order to receive push notifications, an app has to register the device handle on the notification hub. And once the registration is created on the notification hub, the application backend can send the push notifications to it. Now there are three ways in which you can target a specific set of devices to send a push notification. One is broadcast, as I was talking about. So all registrations in the notification hub receive this notification. So when you are doing a broadcast, it goes to all of them. And when you use a tag, so all the registrations that contain that specified tag, only those devices will receive that notification. The third thing is the tag expression. So all the registrations whose set tags match the specified expression receive the notification. So there are three ways of sending the notification using tags and tags expressions. The third feature is the use of templates. So templates enable a client to specify the exact format of the notification it wants to receive. So using the templates, an app can realize several different benefits. So which include So a platform agnostic backend, basically when you set a template, it's not restricted to a platform. It works across platforms. And then using a template, you can send personalized notifications depending on the user or depending on the app. You can customize the notification, how it appears. And then client version independence, that is another advantage of using templates. So it doesn't matter like what client version is installed, like whether it's iOS 6 or 7. So your notifications are independent of that when you're using templates. And then lastly, localization. So if you want to send notifications in different languages to different devices, then you're going to use templates that allow you to localize your notifications. The fourth feature of notification hubs is the security. So notification hubs implement an entity level security scheme called SAS. So this scheme enables messaging entities to declare up to 12 authorization rules in the descriptions that grant rights on that entity. So each rule contains a name, a key value, which is a shared secret, and a set of rights as the listen rights or a full rights. Like you have two kinds of rights that you can provide with each rule. Either you can give full access or you can give listen only access to the app. So Windows Azure Mobile Services give you with the default shared access key and then the full access key. So depending on the need, then you can use those keys to set the push notifications. Now let's see how push notifications work on the Windows platform as an example. So the first step is to request a channel. So then you can, for this you can utilize the WinRT API to request a channel URI from WNS. So this is the notification client platform. So the channel URI will be a unique identifier you use to send the notifications to your application. So first thing is it has to request a channel. The second thing is once you get the channel, you register the channel with your Windows Azure Mobile Service. And then once you have your channel, you can then store your channel and associate with any application specific data such as user profiles. And then until your service decides that it's time to send notifications to the UA channel. So it will be there, and whenever you want to send the notification, that channel will be utilized. The third thing is like to send the notifications to your channel. So you're first required to like authenticate against the Windows notification services using OAuth2 to retrieve a token that is to be used to send each subsequent notification through WNS. And then you can use the push.wns namespace to exceptionally accomplish this task. So first thing is requesting a channel URI, registering this channel URI with the cloud service, then authenticating, getting the token, and sending the push notification. So in Windows notification services, there are these 4 steps that are involved. So basically integration with WNS to provide toast, tile, and badge notifications. You can choose what kind of notification you want to send to your Windows 8 apps. Toast is like something that comes on the screen and then it goes away on its own after a specified interval of time. A tile is an update that appears on your live tiles that are available on the Windows 8 home screen, and then badge is like it comes on the top of the screen. Second thing is the portal captures a WNS secret, client secret and package SID, and then WNS also provides you a clean, easy object model to compose these notifications. And then WNS also performs the authentication against WNS that is required to get a token, basically, to send the notification. So that is about the push notification functionality available with Windows Azure Mobile Services. Let's talk about authentication mechanisms that are available on Windows Azure Mobile Services. Now, as I was talking in the beginning on the first slide, as you saw, there are different authentication mechanisms that you can use with Windows Azure Mobile Services. You can use the Microsoft account, you can use the Twitter account, you can use Facebook or Google accounts. And recently, Windows Azure Services also provides Azure Active Directory authentication as well. So apart from these four, you can use the Active Directory as well. There are two kinds of authentications available. Either you can use the server or the client authentication. A server authentication is where you will display the user with a dialog where they can enter the username and password for any of these accounts. And the client is like, say for example, if you have already authorized and then you have a token, then you can directly use this token to authenticate against any of those accounts. So those are the authentication mechanisms. And then there are table level permissions for each CRUD operation. Now, as we talked about, like when you create a Windows Azure mobile service, you get a database along with it, the SQL database. And that SQL database contains tables. Now for each table, you can set specific level of permissions, like for each operation in fact, like for insert, update, delete, like who can do insert, who can do update, who can do delete, and who can read the data. So for each of these operations, you can set, like say for example, if you want to set read, you want to allow everyone, then you give everyone. And for insert, you want only authenticated users, so you give authenticated users for insert. So there are four levels available in that fashion. One is everyone. So basically here you are allowing everyone to do that operation, whatever it might be, insert, update, delete, or read. And the other one is anyone with application key. So application key is something that is generated when you create a Windows Azure mobile service. So that's a unique key that is unique to your subscription. And then you can use that key within your app and pass it along with each request. And then if you have set the permission as anyone with application key, so they can update the data or read the data. And then the third thing is only authenticated users. So we just talked about authentication, like using those accounts like Microsoft, Twitter, Facebook, or Google. So operations will be allowed only once they have been authenticated using those accounts. So you have to send the authentication token along with the request, so it will be validated, and only then that operation will be performed. Lastly, there is only scripts and admins. So if you do not want the apps to update the data in a specific table, then you can set it to scripts and admins. Then only the administrators for the portal, or if you write any custom scripts inside any of the different tables or somewhere else, those can manipulate the data in that particular table. And then apart from this, you can also have more granular level control with server-side scripts. On the user level, you can have either admin, authenticated, or anonymous, and then you can also use the user ID if it is not authenticated. So those are the authentication levels available on Windows Azure mobile services. Next we're going to talk about the monitor, alert, and scale, which is basically the diagnostics that you see. So once you log on to the portal, you can see all the information regarding your Windows Azure mobile service. It will show you the number of API calls made to that service. It will tell you the CPU time that has been taken to respond to those API calls. And then you can see the data output, basically how much data was transferred from the account. And then for scaling, you have two options. Either you can scale on compute or you can scale on storage. So compute scaling is basically between shared and reserved mode. So you can increase and decrease your instance count. So you can increase the server instance count depending on the usage, or scale up the VM size itself. And then storage is like for your SQL Azure database, you can upgrade to business level, which allows you up to like 150 GB of SQL Azure database. And by default, you get a 5 GB database, which is actually or 1 GB, I guess, which is free with the default Windows Azure mobile service. Lastly, you can also do logging, there is a console.star namespace where you can use console.log method or console.error method to provide easy means to debug your server-side scripts. Say, for example, if you're writing server-side scripts to insert or update data, then you can write console.log, console.error, and then you can see those see that output on the logging screen. So that's about the diagnostics and scaling of Windows Azure. As part of the demo, I will show you like how to create a Windows Azure mobile service using the portal. I'll quickly just run through that. So here you can see that I have logged on to the Windows Azure portal already. So there is a tab for mobile services. Now you see that I have already created one. So if you want to create a new one, you can just go here and say new and select mobile service and then say create. You have to give a URL here, say test. So test environment. You can give whatever name you want. If it is available, then it will show you whether it's available, and if it's not, then it will give you a red mark, and then you can change the name. You can use an existing database here, or you can create a free 20 MB SQL database that I was talking about, or you can create a new SQL database instance. So now because we already have a web service already there, I'll not create one here. So we'll just go inside this. It has a database already available. Now you see here it gives you sample applications for Windows Store, Windows Phone, iOS, Android, HTML, JavaScript, and Xamarin. So it will directly give you a sample app that you can customize based on your needs, and it will create one table which is called as the to-do item. So this is the database that we had created. So if I go to data here, so there is one table that you see which is the to-do item. And if you see permissions, this is what I was talking about, like the different level of permissions that you can give on a table. You can give insert permissions such as only authenticated users, or everyone, or anybody with application key, or only scripts and admins. So if you want to write any scripts, so here you can write your script like on insert, update, delete, or read. So you can just create a Windows Azure mobile service and download the sample app to see it work. So it takes hardly 5 minutes to actually do that, as we've seen here. So that was all from my side. I think we've covered all the topics here. And if anybody has any questions, they can type in the chat window, and then I can answer those. Thank you, everybody.
Hey, thanks, Amit. It was a wonderful session. So just give us a minute. People have started typing the questions, and we can take these questions now.
Sure.
Okay. Okay, here is the first question, Amit. One of the participants asked, what is dynamic schema?
Okay, dynamic schema, as I told, was like basically you can turn it on or turn it off depending on your requirements. So say, for example, if you're not sure about how many columns you want to have in your table, then you can just create whatever is your requirement right now, and then depending on the data that you're storing in the SQL database. So say for example, if I created one table called as the to-do item table that we just saw, say to-do item, and then if somebody wants to have a due date, what I can do is I can add the due date to the data and then insert the record. So what it will do is, because that column is not existing, it will add a new column called as due date, and then it will insert the data that you're sending. So that's how the dynamic schema works.
Great. Thanks, Amit. So here is the other question. What are the authentication types supported by Windows Azure mobile services?
Sure. Windows Azure mobile services supports like 4 kinds of authentication, basically, like Microsoft account. That is, you can use the Microsoft IDs that the users have. They can use those IDs to log in. And then there is Facebook, Twitter, and Google. So any user, if they have an account on either Microsoft, Facebook, Google, or Twitter, you can create an app that will accept those user IDs. So you don't have to create your own authentication mechanism. So basically, you're also integrating your app with social networking sites along with this authentication. So, and apart from that, recently Azure has also provided Active Directory authentication also. So that works on Windows Azure Active Directory.
Okay, great, thanks. So here is the other question. How to use validation on dynamic column?
You can write scripts, basically, like when you insert update, and then in those scripts you can do validations that you want. But most of the validations you might want to handle at the application level itself. Because what Windows Azure Mobile Services is providing is a backend, basically. So there is a service with which you can insert the data. But if you want to do some validations, I would suggest that you go with that in the application itself, before actually calling the website and storing the data.
Okay, thanks, Amit. Thanks. So let's take another question. So what other options are available to store data apart from SQL Azure database?
Apart from SQL Azure, you can use either Windows Azure tables or Windows Azure blobs. So these are basically like cheaper options when compared to SQL database itself. And moreover, more important than cheap, like depending on your requirements actually. So if you do not have any relational data to store, you can easily go for Windows Azure tables. And because they are natively available inside the Windows Azure platform, the access time is also much faster compared to SQL database.
Okay. Yeah, thanks, Amit. Thanks for the clarifications and thanks for the information. And I hope we have answered most of the questions now. In addition to this, in any of you folks have any questions, you can please drop us mail at marketing@winwire.com, and we'll ensure that our experts respond back to you on that. And thanks, Amit. Thanks for the wonderful sessions, and have a good day to everyone. Thank you.
Sure. Thank you, Noor. Thank you, everybody, for joining this session.
Thank you.